Basically, Dr. Sara Simon holds an MS and a PhD in mechanical engineering from University of Wisconsin-Madison and has extensive experience leading cross-functional projects in design, prototyping, and validation as a project manager at Forward Engineering. I think we saw a lot of that already. Currently, she's serving as the Global Sector Manager for Composites and Thermosets at NETZSCH Instruments North America. She has experienced a true full circle moment that demonstrates how early student engagement can evolve into meaningful leadership roles within the composites industry. So with that, I'll hand it over to Sara. Yeah.
Great. Well, thank you. So let's get started. So as mentioned, it will be an open house. So I was asked to share a little bit about my journey, how I first got into composites, why I decided to move from academia into industry. And along all of that way, I will be giving some useful tips and tricks. And afterwards, we're going also to look at the prospects are currently out there in composite, what are opportunities, where are they looking for people, and so forth. So okay, so let's get started. Let's get started with the first part. So many might not know, but I'm actually not a mechanical engineer. I started my college experience in biotechnology in Austria, and then during the time gained my first steps in composites, then made it official to move from biotech to mechanical engineering with special focus on polymer engineering. Then I joined UW Medicine, becoming a researcher after graduation of my PhD. I headed into industry and recently did move jobs to NETZSCH Instruments North America. Okay, so let's kick it off with starting point and first steps in composite. So as said, I was in biotech, so I am pretty good in organic, inorganic chemistry, crop science, botany, microbiology, genetic, cell biology, but pretty much I have forgotten most about these and have moved into a different direction now. And how did I even then touch plastics, bioplastic composite at this point? So there was an elective at my university that I could choose, which was bioplastics, and that's really where I first saw biodegradable beakers being made with a very small injection molding machine, and I just didn't understood how this was made. And now we all know injection molding is a pretty standard process. But back then for me, I was like, oh my goodness, what is this? So I really wanted to learn more about this. So at the end of my bachelor's, we had mandatory internship, and I decided to pursue companies that were in the plastic space. And as you can see me up there, I ended up at a company where I was converting starches into thermoplastic starches and then compounding them with biodegradable polymers, characterizing them, and then moving on to film blowing experiments. The idea behind this was to produce biodegradable plastic bags for the Austrian consumer market. So my student tip at this point would be to really use elective or internships as exploration tools to find out what you might enjoy, find out what you don't like. And also what I would like to add here is that before being allowed in the lab at my university or being allowed to go to companies to work, I always had to mandatory make a very extensive literature review with more than 30 papers, up to 50 papers, to review them, read them, summarize it in a report, and present to the company as well as to the professors. And that I had to pass in order to be allowed in the lab or be allowed at the company. And really making some literature research before you are going to do hands-on activities is really important, because once you are there on site, you already have all your theoretical knowledge ready to go, and you can focus and advance faster in your experimental work. I moved forward to my master, which was still in biotechnology, and then said for my master internship that I wanna go again into the plastic space. For me, it was clear that I wanted to go somewhere else to do that master internship. I wanted to go abroad. I wanted, to be honest, go as far as humanly possible away from the place I was at. Not because I didn't like it, but the university I was from was very small, limited exposure. There were no experts for me to talk about plastics. So I wanted to have a full-blown experience also at the university, where I could not only improve my English as well, my technical, one point I really wanted to do. So I applied pretty much around the globe, but was most successful in the United States, and then ultimately decided to pursue an internship at the University of Wisconsin-Madison. So my student tip here is to really trust your gut. If you're feeling you are stuck or you want to experience something else, going to another state or going a little further away can really help you not only to make more connections, but to build a network and experience other things. So I secured the internship, but that was only the first part of it all. How can I fund this? And this was a 9 or 10 months internship, so I need to have enough money to pay for rent, and we all know as students we're pretty much having no money to do that. So I was applying for a lot of stipends, but in Austria it was pretty much, oh, if you're living in this district and you work in this district, you might be able to get this scholarship. But it was not like, oh, I want to come to the US, I want to do something very far away. There was actually only one called the Austrian Marshall Plan Scholarship, which was 10,000 euros. I think it's like $11,000 or something like this. So that was a big score. But it was also the most competitive of the scholarships. They would only select one person per university per year. And I was really the lucky one and got accepted for this, which pretty much paid my rent, my food, my health insurance, and everything I needed. But in addition, I didn't give up, because I found out I got the scholarship pretty much a week before I traveled. So I was also securing other funds in parallel from local districts as well as women organization. And I was able to get more money to not only pay for my visa, but also pay for the standardized tests that I needed to do, my flight tickets, and other expenses. So I ultimately ended up being able to fund everything I needed for the 10 months in the United States, including the flight tickets. So my master internship was at the University of Wisconsin-Madison. I worked with Professor Oswald, and I worked on fiber breakage during injection molding of glass fiber reinforced composites for automotive applications. And it was a very great project. So my student tip here would be, if you're applying for scholarships, make sure you're casting a very wide net to do that. But in addition, you need to tailor for each scholarship. Later in the presentation, I have a slide just on the scholarships that are currently available to you and might be from interest. So I'm gonna skip this for now, and we're gonna talk later a little bit in more detail. Okay, so I finished my master internship in the US. I came back to Austria and I graduated. And then I was like, what am I gonna do with my life? No, that sounds too severe, but like, what am I gonna do in the future? The only thing that I really wanted, that I knew, is that I really want to work in composites, plastic. That's my thing. I want to do that. But I also had to acknowledge that I didn't have the background for it. I only knew what I knew from internships, an elective and another internship. So I felt like I would not be able to be a successful researcher in that field without having the background. I applied nevertheless in Austria, and I got PhD positions for different bioplastics and other things. But before I left, Professor Oswald said, Sara, if you want, you can come back. But you know, I'm a mechanical engineering professor, so you have to go into the Master of Mechanical Engineering. If you can make it, we can talk about PhD. And I said, but that kind of meant a 2-year setback for me. I would need to get another master. But what I'm trying to say is that it was more really an investment into my future, because if I would go back, I would do the exact same thing for sure. So I came back to University of Wisconsin-Madison, but the transition was very hard. Think about going into advanced solid mechanics without having taken elementary or intermediate solid mechanics. And do that for all the courses that are out there. I was suffering. Like during the day, I was a TA, I was a research, I was doing my classes, and at night, I was in libraries catching up on fundamentals I didn't have. And your picture here is from University of Wisconsin-Madison. We call them the cages at Memorial Library, where you can lock yourself up in a metallic cage, and they're open 24/7. So that was a challenging 2 years, and I really had to say, if I would not have all my university friends from my research group, which pretty much volunteered to be my personal tutor for quite some time, I probably wouldn't have made it. So during this time, I know it's very common as well for grad students in general, sometimes feeling like being an imposter, like I don't know too much. This is very common. It's just important to don't let it define you, because in the end, you know most about your research project than anyone else knows about it. And to think about it is very good and very useful. So after my master, which I made it. I went to move forward with the PhD, and at this point, I wasn't sure if I'm gonna do it or not, because I've already spent so much time in education. However, I decided to pursue it because Volkswagen went to my professor and say, "Hey, we need someone who knows fibers, who knows composite, who knows process flow simulation." And that was me in that time at the group, and I was like, that's pretty cool. It's an industry-sponsored PhD with industry exposure and experience. So I was like, you know what? I'm gonna do this. And I really enjoyed it because the topic really aligned with the current industry challenge, and I could apply my skill directly in practice. So for this, I was traveling to Wolfsburg, Germany, to the VW city 2 to 3 times a year for process optimization, as well as to produce my parts that I would then ship back to the United States for analysis and use it for model validation work I was working on. And I know this is kind of mean, it's not a student tip, but if there are projects from industry that you can work on, it's very good, because an industry-sponsored PhD is paying for your salary and your research expenses. It puts you as a student in a very strong position. And I know it's great to have, but sometimes you're also at a point where you cannot make this kind of decision. I also want to acknowledge that. So I was lucky to be in that position. Okay, so now I would like to talk a little bit work beyond the lab. And we will be spending a couple of slides here. So I was doing my classes, I was a TA, I was doing my research, but I was also involved in consulting work with industry while I was a student. So I noticed that my professor would ask other more senior students in my group, "Hey, I have this consulting work, can you help?" And I was like, I want to be asked, I want to do that too. And so I said, "Hey, do you have anything?" And he said, like, "Yes, I have this thing, you want to work on it?" Did I know what to do? No. But was I willing to find out or work with my colleagues? Yes, definitely. And I really would encourage you, to go to your professor and say, "Hey, do you have anything with consulting, like work from industry?" I know it is extra work that you have to take on besides all of your very, very busy schedule, but it exposes you to other projects and other topics, and you can always learn on top of it. For example, I was working on, in this example, on a direct fiber modeling. At the bottom, you see fiber-fiber interaction. At the top, you see a virtual rheometer where we expose a simple shear flow to track how fibers were orienting with the flow. This was work that was used for modeling work, validating new fiber breakage models, and so forth. But I was not familiar on that there's a code in Fortran, so I didn't know Fortran at all. But I had someone who knew, so we worked on it together, and we were both learning. So that was actually a good experience. So my tip would be, ask your professor if there's something out there. I also want to say, though, don't go unprepared to your professor. Have your sales pitch ready about yourself. like why you're good, why you can take on this works, and what are your strengths and skills that you can bring to table. I also have to note here that if you are an international student like myself, you're not being able to get paid for this because that is based on your visa. If you are a citizen, you might be able to get compensated for the work you do. So unfortunately, international need to do it for the experience. Okay. Also beyond the lab, building visibility and networks, very important. Always scan for opportunities, ways to get involved and connected. And I'm saying this because most jobs are actually coming from people and not job boards. And I will get into that a little bit later. So I want to put an example here. Rising Stars in Mechanical Engineering, Stanford University. Select 30 women a year that, if selected, you can go to Stanford University to find out if an a career in academia is of interest to you. You meet the professor at Stanford, you can shadow them for the day. They tell you what it is to be a professor, that you can see the research lab at their facility, and also connect with peers. So this is something you need to be nominated by your professor though in order to enter. But that should be easy if you send it to your professor. Hey, I'm thinking about becoming like you. I think he will not say, I'm not going to support you on that. Moving forward, also continuing building visibility and networks. Think about attending strategic conferences. I will give the example of Society of Plastic Engineers, the Automotive Composite Conference and Exhibition. It's held always the first week of September in Novi, Michigan. And I first joined there this 2016 in the graduate student poster competition. I came back with a poster in PhD category. I did another poster, I think, in PhD category. I submitted papers, I gave technical presentations, and I got to know the people there, or they got to know me as well. So I said, hey, I want to be involved in this. What can I do? What do you need help with? So they actually said, okay, you can be a session moderator. And I said, cool, I'll do it. And then eventually, and since I think 3 years now, I'm actually part of the executive planning committee for the conference, involved in all parts, like from food to getting money for it, to securing talks, to reviewing paper, and more. And most importantly, I got my first job because someone saw me at the conference presenting. I also was the organizer of the International Polymer Colloquium in Madison, another conference that I was organizing. But other ways to build visibility is also think about publication of shared articles and research. For example, I was a little bit sneaky. When I was going from PhD and thinking about industry, I wanted to go into automotive. And I knew that I needed to, like, for example, vibration testing or some other kind of testing, which I didn't know. So I just added them to my research scope, to my PhD thesis, so I could do it, I could learn it, and I have another chapter in my thesis. So unofficial advice. Yeah, so you can, try all the different things and build up your skills. So my networking formula would really connect at event, conferences, and online. And my secret weapon is networking remembered. If you're meeting someone at a conference and you make a strong connection, the same day, send them, maybe not like 30 seconds later, but in the evening, send them a connection request. Say, hey, it was great talking to you. I would love to connect on LinkedIn because I want to follow your journey for solid state battery development. And they were like, oh, you took extra effort to write the message. Of course, let's connect with it. But then later, if you're visiting, seeing your contacts again and again, you can say, hey, yeah, how you doing? Or if you're even smarter, you say, oh, I know this person works in bioplastics. I know this person works here. You see a new regulation coming out, an article being published, connect with them on LinkedIn. Hey, saw this. I thought it could be interesting for your research. How are you doing? Like to stay on top of mind of people. And as said, with SPE, ACCE, the conference, we're always looking for volunteers because there is just so much to do. Okay, now let's touch on scholarship. I will focus here on Society of Plastics Engineer, SPE, because that's what I'm I'm part of that. So they have the SPE Foundation scholarships, and I put the link at the bottom left. This is just a screenshot on the right of some selected ones. You can scroll this page down, down, and down. There are so many possibilities for that internship. In 2025, there was more than $300,000 in scholarships available for students. And there might be many scholarships. I'm pretty sure there are scholarships that apply for you. Some of them are, oh yeah, you need to be a graduate student, you need to have a 3.5 or higher GPA. You're working in injection molding, we have an injection molding scholarship. If you are in composites, you work in AI, there's like so many different things. So scan through them, apply. Like some of them, because they cannot only, they look good on a resume, but most importantly, they can help either fund you personally, and I think we always need a little bit more money than your students, but it also can cover your research expenses as well, depending on the type of scholarship that it is. So I would really recommend to check this out. How can you find other scholarships? I would really recommend subscribing to newsletters, plastic ones, composites one, manufacturing one. It's most of the time always free for students, and there you find out if there are opportunities out there. If someone looking for a job is like a scholarship, it's going to be mentioned, so you can keep tracking, or you can just search the entire document for certain words to be up to date. Okay, getting ready for job applications. So having applied myself, obviously, and I'm also having hired myself, my recommendation is please always include a resume, a cover letter, as well as work references. I know writing a cover letter is hard work. Please don't use ChatGPT. I'm getting cover letters, which I know this is ChatGPT. I can identify it immediately. I would not say don't use it. Use it as a starter, but then put your own flavor into it. Like ChatGPT doesn't know where you're strong and where you're weak. It thinks you're great always, but like tailor it. You need to tailor it to the position. You need to tailor it to the company. So I know it's a lot of work with each job application you send out with, but it's gonna pay off. Work references carry a lot of weight. It's gonna be your professor. It can be another professor. For example, I had a work reference from another professor at my university because I did the vibration testing with him. I had an industry-sponsored PhD. I used Volkswagen as one of my references. I did consulting work, used that company. But for doing that, please call them ahead of time and ask them for permission that you are allowed to put them on there. They need to be willing to be called and answer questions about you. And what we are often forgetting is, if you're applying, you think about, I need a job, I need a job, I need a job, I need a job right now. But don't forget about yourself. And this, I think, is sometimes what you do. I always recommend an on-site visit. I've been applying to places where I was showing up and everyone I met had the darkest eye circle I've ever seen in the history of life. And I was like, if I'm going to pursue that opportunity, I was like, am I gonna look like this? They looked really unhappy. And I was like, that clearly points towards a lot of overtime, overwork, something. You can say, if you're in the later stages of the interview, hey, can we have this on site? I can come over. Because you can just learn so much more if you meet someone in person and get more ideas about how your colleagues are being and how the entire working atmosphere is actually looking like. For interview preparation, have a slide deck ready, even if it's not requested. There's always going to be the question, what you're doing? And then you say, actually, I prepared 3, 4, maximum 5 slides. Can I pull them up? And I said, yeah, sure. But so you say, okay, if you're applying into industry, say how your research could be benefiting to industry. Like, don't put equation on model development, like your result. Oh yeah, that was what I had to do. That's where I'm right now. That is the result of this. And say, and if you're going a step further, look at the company profile. How could what you do help them out? Like, just think about it, because it just demonstrates commitment. I like ChatGPT though to prep for interviews. I have been loading job roles and my resume into ChatGPT to say, hey, that's the position, that's the company, ask me example interview questions. It also makes answers if you need to, but it helps you, because if you're practicing it at the first time, you're gonna probably be terrible. But then if you're practicing and practicing, and the same questions are often repeating in the interviews, you're getting better. And for me, it was often, the more I felt prepared, the more confident I was. And the more confident I was in the interview, and the better feedback I got after the interviews as well. And another point is, please use plain language. You want people to understand what you're doing, so you can ask questions, so they can ask you questions about it. And often your first round is with a hiring manager that are not necessarily even having technical expertise at all. So be able and be, I know, but sometimes you're so much in your topic, try to explain it to someone who doesn't know. I tried with my mom and my dad. And they're like, sorry, that's way too much. So I guess, okay, let's try again. Landing opportunities after graduation, try to start early. I would recommend at least a year out, and start building a very strong LinkedIn profile. If you can, start your LinkedIn profile as soon as possible. If you don't have one, start now. How can you populate it? You do something cool in the lab, you have a nice video out of it, post it. If it's not, some kind of company funded or secret project you're working on. And then if you go to strategic conferences, you start building your contacts. Don't randomly connect on LinkedIn with people you don't know, because those connections are useless. And if you, most of likely they won't even accept your, so it's not like you need a lot of friends on LinkedIn, you need to have good friends on LinkedIn. Preparation, maximize final years with strategic conferences and trade shows. Face-to-face connections are very powerful. And if you're sneaky and you have a good conversation with someone, you like what they're doing, pull out a CV of your backpack, say, hey, look what I got. You have anything? Keep me in mind. Because as I mentioned before, jobs often come from people and not actual job boards. Ask alumni from your research group. They have gone into industry or have into academia. Ask them about their application package. What have they done? What has worked for them? Maybe they're going to share some cover letters with you, some how their resume looked like, and you can adapt it and structure your information the same way. Also, universities often have a career department that help you review your resumes, or help you improve them, give feedback. Also plan on attending career fairs to connect. And then last but not least, handling rejections in a smart way. I know if you got the 30th email that you're not getting the job, you're getting a little discouraged about this all, but try to not see it that way. Have a nice dinner. Next day or so, say, hey, thank you for letting me know. Can you provide feedback to me? Can you provide feedback? Like very nice language. Can you provide feedback? Because sometimes, first, this leaves the door open. You're not like, why didn't you hire me? Like, it leaves the door open, and that hiring manager says, oh, she's handling, or she's handling this very nicely. So I actually have this another position. Would you be willing to look at it? Or you get actually feedback of why you would not move forward, and something that can be useful for the next interviews that you're going into. Okay, so me going from academia to industry and why I made this step for me, a couple of reasons. I was already part of consulting work, and I had an industry-sponsored PhD, and I have set my eyes on automotive. So for me, the path was a little bit easier. I also really like the fast-paced environments and the more clear career progression I would have in industry. But I also have to say that I was a TA almost all my years. Every semester I was a student. So I had a lot of teaching experience. I found it very rewarding, but it didn't felt like my long-term career path or what would be the right thing for me. And I also have to say, I saw professors I've been working with very struggling with the admin stuff. There's so much paperwork they have to do. And sometimes there's also funding stress to keep all their students supplied with enough money for their research. But for me, what ultimately sealed the deal is that I got a job offer from industry that aligned perfectly. And I showed you guys before, it was the battery enclosure project. So I was like, that's exactly what I want to do. So I said, let's do that. So my tip for you to find out what you really want is to just ask yourself what you enjoy more. Do you like to do fundamental work? You like teaching and publishing? Or do you like to go into fast-paced environments, making products or solution? Yeah, I feel also that sometimes I felt a little bad about leaving academia because I was already in it for such a long time that I thought it was kind of a default solution just to stay there and continue the research I was doing. So just, think about it, take some time, make a pros and cons link of what is important to you and choose the path that is right for you. So as mentioned, I went into automotive as a consultant as well as a project manager at Forward Engineering North America, which was a composite-focused consulting firm with global presence and was specializing in production-based engineering and simulation-driven design, exactly what I wanted to do. And especially I got pulled into as project manager for 2 major composite-intensive high-voltage battery enclosure development programs. And what I was like those 2 projects were kicking off a month later or so after I started. So I saw the entire development. I was part of this. I was part of the design, the simulation, the process flow simulations, prototyping, characterizing, and testing, as well as validation. So just going through this over some of the parts that was being that were made. So at the end of the day, like having this role was absolutely a super decision. I really enjoyed, working on this kind of cutting edge project, and I was able to really see the full development process. I also have to say that when I went into that role as a project manager, I wish I would have taken classes from business school. You think you have a PhD project, you know how to handle a project. I have to say my PhD project regarding this project almost had 1,000 items and activity associated in its project plan by itself. It had so many external partners and deadlines that I actually ended up taking evening classes at university to catch up on those skills that I didn't have. So if there's still time for you now, maybe think about it. Then I moved the role. I went to an opportunity. So why did I decide for the job? So I was allowed to share a part of my job description. It was Global Sector Manager, Composites and Thermosets, which for me was a way up the career ladder, something that I wanted to do. Languages was English and German, and I'm a native German speaker, which already gave me some advantages here. Professional experience, 2 to 5 years. I was exactly in that. But what really jumped out to me is that I would be participating or representing NETZSCH at trade shows, conferences, and all of that. And I always enjoyed doing that. I helped planning conferences. So for me, I really like networking with people. I like to connect with people. I like to work with universities on case studies. I was doing competitive analysis, observation, regulations, and standards, collaboration. So a lot of those things I really like doing. But most importantly, I wanted to work with Professor Natalie Rudolph. Natalie was a former professor at UW-Madison, so we knew each other from the time before. And she's smart, she's funny, she's an absolute perfect leader. And I was like, you know what? I like the job, but I even more like working with her. So as I mentioned, like it was the path towards management track. And the role really blended what I had with my technical expertise, networking, university engagement, marketing, and business growth. I also really like the global scope to the work. So I will be sent to Australia, South Korea, China, Brazil, India, places I have never been before. So this is something that really jumped out to me. I was like, oh yes, I wanna do those things. So what have I done so far at NETZSCH? I mentioned it before briefly in the other seminar. I really have experience in process flow simulation, so there will be a new team built around that I will be leading. Materials and technical experts on call. I've been traveling the last 2 months by giving talks at conferences and so forth, visiting universities, strategy and outreach, and also academic collaboration. So if you have anything, a case study or something that you would like to do with us, let me know. I would be really happy to help there, free of charge. Okay, so the key takeaways that I want you to hear is, unfortunately, you have to go the extra mile. You need to be, initiative and persistence is just something that keeps you apart from the other people that apply as well. So if you have been involved in conferences, if you do some consulting work, that is just gonna something you can put in your resume, and also something you can show in your demonstration on what you have done. It just makes your skill profile bigger. Stay visibly and network authentically. Make sure that your relationships are genuine and that you are genuine yourself as well. Because if you make connections with people who you know, like last 10 minutes or so, to focus on the future prospects in composites. How does the market currently look like? Where are the opportunities, especially for you guys? Which areas are hot? So looking at the report, plastic industry has been historically one of the very strongest one, and it has been growing 1.1% annually, which is very promising. But we also have to say that currently there's a lot of uncertainty when it comes to tariffs and so forth, which is also dampening the situation, making some of the outlooks a little bit more carefully and cautiously at that point. So at the moment, there are more than 1 million people hired in the plastics field. If we take all the suppliers in mind as well, there will be 1.55 million people. On the left side, you see the table where there are the most jobs depending on the state that you are in, where Texas, Ohio, and California are leading with the amount of jobs that there are available for people exactly like you. And as said already, the outlook for 26 is a little bit cautiously, just because of all of the tariffs and other political things that are currently going on. What we could also see is that for Q3 of 2025, there are a bunch of jobs that have been added. However, not as much as in the previous year, which lets us think that the labor market might be cooling down a little bit. However, when looking at unemployment forecast, it's steady, as it has always been throughout the year. But don't get discouraged by this. There are jobs in plastic, especially rubber is coming back. So if you have experience in rubber, we are actually currently looking for a new global sector manager in rubber. And there's always a shortage of skilled individuals just like yourself. So let's look a little bit about the sector of manufacturing, automotive, and aerospace. Manufacturing is increasing 1.1% in 2025, with an expected increase of 1.6% in Q4. So there are opportunities for you there when it comes to manufacturing. Automotive reports say there's a strong demand. However, some of the sales number of the vehicles do not necessarily support this. People are a little on the safer side right now, might not be pushing new projects because just of the tariff uncertainty associated with that industry right now. Aerospace is very hot. Growth supported by defense spending and recovering air travel demand. The average output for 2025 is a 10.6 increase, but looking at Q4 of 2025 is a 22.5% increase. So there are lots of jobs right now in aerospace. Okay, so now I just want to give an example from automotive from Volkswagen. So even though numbers are a little bit cautious, like a little uncertain right now, there are opportunities in the right fields. So Volkswagen is a very progressive, no, that's not the right word, like forward-thinking OEM who has strongly committed to the sustainability approaches, like what to do with vehicles, end of life, circular economy type of approaches. In fact, they stated publicly that they are prioritizing recycled materials from production waste and end-of-life projects. But even more importantly, they said that every new material, every new vehicle you make, the material, if you're suggesting a new one, has to have a life cycle analysis attached to it. It tells you about the carbon footprint and among other things, but this life cycle analysis needs to be better than the current material that is being used for this specific part. If it's not, you have no chance to give a new material you might develop getting into that kind of automotive applications. They also put recycling inside their design standards. They have very, very strong circular material targets. By 2040, they said that 40% of all of the materials in vehicles, excluding China, to come from circular resources. Another responsible material sourcing. So there are, like, the key takeaway is that there are a lot of opportunities when it comes to biopolymers, what to do with vehicles end of life. Because if we think about it, some of the vehicles that are ready to be shredded or are at the end of their life are like 20 years old or older. What kind of plastic materials were used 20 years ago? And then if you shred all this up and you need to make materials out of it, what can I use? How can I use this for? What am I doing with this type of material? So there's a lot of opportunity in this, and the rules that VW has communicated is also valid for the United States. So future prospects, composite trends that I've seen, as well as some of the conferences I have attended lately, regarding industry direction and key drivers, sustainability and high rate production are seen as key priorities. And as mentioned before, the OEMs demanding full environmental accountability is coming. And electrification is still a big topic. When it comes to manufacturing and process trends, we're going towards automation, and I've seen some of your work you're doing right here, which supports this. Digital process control, data integration, smart sensors, smart composites with embedded sensor for real-time structural health monitoring. So some of those points are overlapping with each other, of course. We already touched on it. Sustainability, recycling, and biomaterials. Biomaterials, as well as natural fibers or natural fillers, are making a huge comeback. I've seen it in the past conferences. There are so many talks on this topic. So if you're working on this kind of stuff, just think about that. In the end, you need to show LCA on those kind of materials, and don't forget the cost. So if you're looking at OEM, you always need to, OEMs are super cost sensitive. If you have a material that might perform better on an LCA, but it's 3 times as expensive, they say, no, thank you, we're gonna stay with the material we're currently using. Sustainability, recycling, and biomaterials. I said natural fibers, recycling, life cycle analysis, and push for closed loop recycling and waste reduction. Particularly for aerospace and automotive, we see next-gen single-aisle aircrafts going into the service by 2030 approximately. They are requiring up to 100 aircraft to be manufactured per month. So making this possible with automation and so forth is going to be a huge topic. And then still composite use still expanding when it comes to EV structures, battery enclosure, as well as automotive or aerospace in general. So with this, I'm at the end of my talk. I hope I was able to provide you some insight from my journey, some tips and tricks I learned along the way, and now it's your time to ask me anything that you want.